All right. Section 5.4, day 2, we're solving radical equations and inequalities. So when an equation contains a power with a rational exponent, you first isolate the power and then raise each side of the equation to the reciprocal of the rational exponent. So example 5, solve 3x, quantity raised to the 3/4 power, minus 2 is equal to 25. So just like we did with radicals, we want to get the rational exponent by itself on one side. So first thing we're going to do is we're going to add 2. So if I do that, then I'll have 3x raised to the 3/4 power is equal to 27. So now we're going to raise each side to the reciprocal of 3/4 or to the 4/3 power. All right, so I'll write that down here for you. So we're going to say 3x raised to the 3/4 power and we're going to raise that to the 4/3 power. And we're going to take that 27. We're also going to raise that to the 4/3 power. Okay, so now we're going to simplify. So I want you to remember, we talked about this earlier. We can write this as 27 to the 4/3 power. We can write it as either the cubed root of 27 raised to the 4th power, or we can take the cubed root of 27 and put the 4 underneath. So again, you just have to kind of ask yourself which is easier to solve. All right. So in this case, it's going to be this one here because we know that the cubed root of 27 is equal to 3. So since that's the case, then we'll have 3 raised to the 4th power. So what is 3 times 3 times 3 times 3? Well, 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Or even if you plugged it in your calculator, you would still see that you would get 81. All right. So now right here, remember, when we took this one here, those two are just going to cancel each other out. So we're just going to have 3x is equal to 81. And now we're going to divide by 3. And when we do that, we will get that x is equal to 27. Okay, now we're going to solve one here. So we have x plus 1 plus 12, all of that raised to the 1/2 power is equal to x. So again, if you think about this one here, we're going to square each side. Because if you think about it, 2 is the reciprocal of 1/2. So we're going to take and we're going to do x plus 12 raised to the 1/2 power. I'm going to square that. And then I'll take the x here and I'm going to square it. So on this side here, again, if you think of it as 2 over 1, that becomes 1. So on this side right here, we're just going to have x plus 12. On the other side, we have x squared. So again, we're going to write this in standard form. And when I do that, again, think about it. I'm going to move that x over. So it's going to become negative. I'm going to move that 12 over. It's going to become negative. And then I'm going to set it equal to 0. And I kind of flipped it for you. So now we're going to factor that. Hopefully we're getting good at factoring ones with a coefficient of 1. So again, I have an x here and I have an x here. I look at this sign here. It's negative. I know automatically one's positive and one's negative. And what are factors of 12 that will give me a negative 1? So he would tell me it's minus 4 and plus 3. Set that equal to 0. Again, we're going to solve that. So we're going to have x is equal to negative 3, or x is equal to positive 4. And what should we do? We should check. What are we checking for? Extraneous solutions. All right, so I'm going to check x is equal to negative 3. I'm going to take negative 3 plus 12 raised to the 1/2 power. Our question is, does that equal negative 3? Well, negative 3 plus 12 is 9. 9 raised to the 1/2 power is 3. And 3 does not equal negative 3. So that one is not a solution. What about x is equal to 4? Because remember, both of them could also not be solutions. So let's see on this one here, we're going to have 4 plus 12 raised to the 1/2 power. Does that equal 4? Well, 4 plus 12 is 16. 16 raised to the 1/2 power is 4, so 4 is equal to 4. So our solution then on this one here is x is equal to 4. All right? So again, we always have to check these ones when we're solving for extraneous solutions. Okay? And then to solve a radical inequality of the form the nth root of u is less than d, where u is an algebraic expression and d is a non-negative number, raise each side to the exponent n. This also works for greater than, less than or equal to, and greater than or equal to. So example 7, solve each inequality. So we have 3 times the square root of x minus 4 is less than or equal to 8. So step 1, you're going to solve for x. So again, we're going to take that negative 4. Again, we need to get x by itself. So we're going to take that negative 4 and we're going to add it to the other side. So 3 root x is less than or equal to, well, 8 plus 4 is 12. So now I'm going to divide by 3. So I'll get that the square root of x is less than or equal to 4. And then I'm going to square. Again, how do I get rid of a square root? I square it. So I'm going to square this side. And I'm going to square this side. So that'll tell us that x is less than or equal to 16. So step 2, consider let's spell that right. Consider the radicand. Remember, that's what's underneath the radical sign. In this case, since it's a square root, we know that it has to be greater than or equal to 0. That means, of course, that it can't be negative. All right. If it was negative, we would have to have um, imaginary numbers, but we're not talking about those this chapter, or at least on this one. So we know that x has to be greater than or equal to 0. So if that's the case, then we know that x has to be greater than or equal to 0. So I can write that as x is greater than or equal to 0. Notice I still said the same thing. And it has to be less than 16. So it has to be between those two numbers. Okay. All right, let's try it for this next one here. We're going to do the same kind of steps. So for b, we have 2 times the square root of x minus 2, and that is greater than or equal to 12. So step 1 on here. Again, notice we're still trying to get the radical by itself. So in this case here, we're going to divide by 2. So then we'll have that the square root of x minus 2 is less than or equal to 6. Again, to undo a square root, we're going to square both sides. If that's the case, then we will get x minus 2 is less than or equal to 36. Now we're going to add 2. So we'll get that x is less than or equal to 38. Now on this one here, the radicand, what's underneath the radical, cannot equal 0. It has to be greater than or equal to 0. So in this case here, what's underneath the radical? It's x minus 2. On the top one, it was just x, and we said that x had to be greater than or equal to 0. On this one here, now since it's x minus 2, we know that that has to be greater than or equal to 0. If I solve that one for x, I'll get that x is greater than or equal to 2. So same kind of thing here. I'm going to say x is greater than or equal to 2. Notice I still did the same thing. And that it is less than or equal to 38. And that is our answer for that one. Okay. Thank you.